So open your MATLAB.
Sir, in the attendance window, it is showing as late attendance.
Yeah, that is not a problem because the time given from 2 to 5. So all of you open MATLAB. And in command window, you type Simulink, or you can click here, this Simulink button. So both will open. Simulink browser. So you can type Simulink here, or you can click here. So it will pop a window called the Simulink. So in this page, start page of Simulink, you click the first one, blank model. So in MATLAB command window, you have to either enter Simulink or can click here. It will go into this window. So it will open this Simulink window. You can click this library browser. It will open Simulink library browser. So this one is Simulink window, and this one is library browser.
No.
So all of you done this.
So the Simulink is still launching, like it's not fully open yet.
Yeah, it will take some time. So you are completed time response analysis, the control system course.
No, sir.
Block diagram reduction you are completed.
Yes, sir.
Yes, sir.
Yes, sir.
Signal flow graph.
Yes.
Yes, sir.
What?
Yes, sir.
Signal
We are
flow?
currently doing that.
Okay. So both are equal only. Block diagram reduction and this Mason gain formula or something like that. After that, we can start that modeling part. So signal flow graph, that path, forward path, loop, non-touching loops, those things are covered.
Yes, sir.
Yes.
So you know the Mason gain formula also.
Yes, sir.
Okay. So if it is open here in the Simulink library browser, left side of that there is a commonly used blocks. So whatever things you are using commonly, that will come here in the commonly used block. So in this PC, I am using this type of things. So it is coming here as commonly used blocks. And second one is continuous block. So in continuous block, you will get derivatives, integrator, second order integrator, first order hold, and transfer function, state space. These things are there in continuous blocks. In dashboard, you are not using. Discontinuous blocks, there are non-linear elements, hard non-linearities like Coulomb friction, dead zone, saturation, like that things are available in discontinuous blocks. And discrete things you are not using because it is a Z domain. So you might be using in signal and systems or digital signal processing. These are in Z domain. We are dealing with the Laplace domain. And these are the logical operator, lookup tables, and math operation. These math operations you are using commonly. These gain blocks and summation, the summation blocks, add blocks. These things you are using regularly. So these continuous blocks, math toolbox, again signal attributes and signal routings. These things you are using commonly for this control system lab. And main part is sinks and sources. The sources are, if you want a DC power supply, you can use step function. If you are having a sine, this is just like your function generator. So you know about function generator, you can create different type of waves, and you can adjust the frequency, amplitude, everything. So like that, the sources you can have these many sources. Here is a time clock also. You can use for time and the ramp function, pulse generator, repeating sequence, and you can use from your own. You can create a Excel file and you can import from this Simulink. And the sine wave step functions and ramp sometimes you are using regularly, and this clock also. These are the sources. The sources are just like your function generator or power supply like things. And the sinks are just like your CRO. If you are using this scope, it is just like a CRO. And there is one more thing, to workspace. So whatever things are here, it will, you can save it in workspace of the MATLAB, and you can plot it from there also. So this is to workspace option is there, and XY graph is there. This floating scopes and other things are there. You can save to some .mat file also, that is to file, and display is there, some digital value it will display there. So these are the sinks. So sources and the sinks are, sources are your power supplies and sinks are just like your CRO. So first program you can use creating a DC power supply and measure it. So first one you go to sources and drag and drop this step function here. Drag and drop it there. So the step function will be coming in the Simulink file. And from the sinks, you select the scope, drag and drop here. Now you have to connect these things. So you have to click on, right click on this step function. These are the output arrows. This arrow is output arrow. From here you can draw this line. So it will be, arrowhead will be there, and here you can clicking here, it will complete the arrow from here to here. So if it is a break arrow, it will show red line. If it is exactly connected, it will show this black line. So now this step function is connected to this scope. So now we are simulating, you will get the step function. You double click on that step function. Here step time is 1, initial value is 0, and final value is 1. So step time is the time from the step function is starting. So if you are having a step time scale here, the amplitude here. So this is 0, this is 1, 2 like this. So step time is time where the step function is starting. So step time is 1 means it will start from 1. And the output amplitude is 1 means this will be 1. This step function you are using, double click on this step function, step time is 1 and final value is 1. You will get something like this. Step time is time where the step function is starting and final value is this one. So you can simulate this one. Run button, you click it. So it will complete this one 100% compiler that compiled. Click on this scope, double click on that scope, you will get this step function. It is starting from 1 and amplitude is 1. Now you can change the amplitude. Step time is 0 and the amplitude is 2. Again you run it. So it will be starting from 0 and amplitude is 2. So like this you are getting, directly you are connecting a power supply to a CRO. So if you are giving 1 volt, you will get display 1 volt there. So just like that one only. You got it?
Yes, sir.
So you do it.
Yes, sir.
You are completed this one. You can use final value 1. Now this one I am deleting. So now you can enter a transfer function. So for entering transfer function, you go to continuous block. And in continuous blocks, you select this transfer function. Drag and drop it here. Double clicking on this transfer function, you will get numerator coefficient 1 and denominator 1 and 1. So last class we have discussed about this one. So n is equal to 1 and d is equal to 1 space 1 and tf of n comma d, it will create 1 by s plus 1 as transfer function. So
Yes,
this
sir.
This is the system transfer function. Last class we are done using MATLAB. Like that on here only. If you are using numerator 1 and denominator 1, it will generate this. TF is the command, and this command is in this block. If you are using this block, that command is embedded in that block. That S is defined and everything is defined there. So you can enter a transfer function. This F is equal to mx double dot plus bx dot plus kx. So last time I done with some m and b and k. M is something, b is something, and k is something. So m you take it as 10, b as 6, and k as 5. So you can enter this in two ways. So this transfer function will be 1 by ms square plus bs plus k, x of s divided by f of s. So x of s divided by f of s will be 1 by ms square plus bs plus k for a system like this. M is there and this damping is there and the stiffness k is there, and you are applying a force here, it will move x. So the x of s upon f of s will be ms square plus bs plus k. So in having a damper, that is a friction between these two. If the damper is not there, that is called undamped system. So this damping value is 0 to 1. This is called underdamped system. So you can enter it directly these values here. So m10 b6 and k is equal to some. So you can either enter 10, 6 and 5 here. Then you will get, so numerator by denominator, if you are dragging this one up, it will show 10s square plus 6s plus 5. Either you can enter like this, or else you can use this m space v space k. M space v space k and enter it. And you define those m, b and k in a .m file. So clc clear m is equal to 10, b is equal to 6, k equal to 5. Now you have to save this one, and you can run those things. Save. Save it and run it. So it will be saving in the workspace. So now I am entering small m, small v and small k. So this is saved in the workspace. So now I can run this one. You just drag and drop it here. From here you drag and drop it here. So you run it. So it is completed. Then you will get the response like this. So now it is showing 0 to 10 only. So this, you can vary this one by clicking this here and display. This limits you can change. This limits you can change it. For logging data you can change here.
Sir,
Time, but
sir, can you show once again how did you get that pop-up window?
you click here,
Thank you, sir.
configuration parameter. So time you can user defined you can use. Other auto scale you are using, it will scale to auto. So if you are clicking here, it will auto scale it. Otherwise, you can save these things to Workspace. For that, you have to open from Sinks to Workspace. You have to drag and drop it here. The variable name is Simout. You can change to some Y. And the save format, you have to make it array. So from the to Workspace option, you drag and drop it here. And double click on that variable name you can change to Y, and save format you have to make it array. Play OK. So out.y it will save as out.y. So from the sources you select this clock, and this out also you right click and drag it, it will copy. If you are right clicking on block and drag it, it will copy. The out.y you make it t. So out.t and y. You connect this t to this clock and out.y to here. Again you are running this one. You will get this kind of response only, because we are simulating from 0 to 10 only. So where you are getting this 0 to 10, that is the stop time here it is given 10. So it will stop simulation after crossing 10 seconds. So you can increase those things, increase it to some 30. And again you run it, you will get this 30, 0 to 30. So stop time now it is 30 only. That is why you are getting simulation of 30 seconds. Earlier it was 10, so you are getting only 10 seconds. Now I am getting the output from here to 10 seconds. Now this out.t and out.y will be saving in this out. Inside this out, you will get out.y and out.t. And command window, your plot out.t comma out.y, you will get this same plot. So you will get the same plot in MATLAB command window also. If you are plotting out.t comma out.y. If you are using earlier version, you are just giving y means it will display y only, and here you are giving output file variable name t, you will get t only. For new versions, you will get out.y and out.t. Inside this out, it is saving y and t like that. So if you are plotting out.t and out.y, you will get the same plot. If you are using earlier version, plot a t comma y, you will get it. So which version you are using? Like that, you have to modify this plot command also. So same plot you will get. If you are using two workspace means it will save in the workspace. Here in the workspace, in command window you can plot or you can save these things using these kind of things.
Sir, what is the clock time?
This is not the clock time. This clock is decimation is 10 only. That's simulation time we are adjusting here. The stop time. here only, in the top. So here you are using 10 means it will simulate up to 10 seconds only. So in your case, if you are using scope, sometimes this kind of display you will not get. That time you have to click on this one, and time span you have to check auto, and this login, this limited data points will be there for 5,000 samples. You untick those things, limit data point decimation, these things you untick, and this time auto you select it, then you will get same display as mine. Otherwise, sometimes if the data points are high, means more than 5,000 samples, the data points will be sampled. So I don't know which time scale step it is simulating. That things we can discuss after this. So all of you complete this one.
So I have a doubt. Like, when we use this, like safety workspace thing, like, how can we access that in the MATLAB?
It is actually MATLAB, part of MATLAB only Simulink.
Yes, sir.
So to workspace means it will save in the workspace of the MATLAB.
Like in my workspace, like this, will it come as extra variable as?
Yeah, this out will come.
Okay, okay.
This out now.
Yes, yes, sir.
Yeah, this is having T out Y.
Okay, okay, okay.
These things, all the things are there. So this out, inside that out it will saving. So if you are using earlier version, you can directly see this. It will create some Y T like that. Those
Okay, okay.
variables will be created inside. So new
Thanks.
versions it will save as a out dot Y, out dot T like that only. Because it will save it in entire things in out, and inside out it will save like this. So it is showing now, you can see that it is 58 cross 1. The sample size is 58 cross 1. So it is simulating up to 30 seconds. Then the sample is 58. So it is dividing that one by 2 only. So 0.5 seconds is the sampling time. Sampling time for this system. Because I am using the auto solver of the Simulink. So now we can see how to edit that. So now so if you are using earlier versions, go to configuration parameter, like that things. If you are using new version, simulation, debug, and then modeling. The third one, simulation, debug, and modeling. In this modeling, this model settings you have to click. If you are using earlier versions, this control design configuration parameter, like that things you have to go. So model settings, or you just press Control E. Control E, it will open this model configuration parameter. So here you can see start time is 0 and stop time is 30. And this simulation using variable step. The solver is variable step it is using, and solver is automatic solver. The MATLAB is taking some automatic solver and solving these equations. And this solver details you can see these kind of things. So in our simulation, we are not going to use variable step. We are using fixed step only. So how to select this one is you just click on Control E. Once more, Control E. It will pop up the solver data input. Those things you don't worry about it. You have to use the solver only. And the solver selection, you have to use fixed step, and solver you have to use ODE for Rangakutta method. You are studied about Rangakutta method?
No, sir.
No, sir.
No, sir.
This semester
No,
maths,
sir.
I think you will study these things. Numerical integrations is there in your syllabus? Numerical integration.
It was.
Not this semester.
So which semester it was?
First semester.
Numerical, trapezoidal method, Simpson's
Yes.
one-third rule. Those things you are studied now.
No, sir.
No, sir.
Then now you will study fourth semester. So there are so many things are there in Simpson's one-third rule, and there is powerful solver is Rangakutta method. That is ordinary differential equation solving using Rangakutta method. And the fixed step size is 0.001 you have to use. Fixed step size is 0.001. What it is doing is, if you are having a function, it has to integrate. So for integration purpose, we have to select the sampling. So if it is sampling like this, so this is the sampling frequency, then it will, from here, it will draw a line like this. So like this, it is integrating. This area under the curve, it is following as this one. So this is a predictor corrector method is or ODE4. This is trapezoidal method like this. It is creating some trapezoidal like thing. So if the sampling frequency is very high, because this is very high, it will create as an analog signal. So if the sampling time is very less, if you are having a curve like this and you are sampling these points, it will create one like this, T like this, and like this. So you will get output like this, but you want a output like this. So you have to reduce the sampling time. Earlier you are getting some 58 samples only. Now if you are using 0.001 and 30 seconds, you will get this much sampled values. And the curve will be looking very good because that integration is taking more samples. So like that only MATLAB also doing. MATLAB is actually a digital computer. So it is digitalizing signal and using some numerical integration techniques. It is solving these equations. So configuration parameter is, we are setting the integration routine. So fixed step we are to use. Earlier that variable step means the step will be varying. So here it will sample one. Someday after some frequency it will sample more. So that is MATLAB determines how it is doing. So now we are determining how we have to do. So fixed step and ODE4 and fixed step size is 0.001. Click apply and OK. Then you run it. It is a linear system, then it won't affect much. You are running same thing here. You will get same plots. So this is how you have to do. Now you are clicking this out. This parameter now 58 to 30,001. That many samples you are getting. Now you are using this scope. You will get like this. If you are limited this logging display to 5,000, that 25,000 sample will be disappear. So some of you are having some problem with this one. You are limiting this data points means you will get last 5,000 data points. So now I am using this unticked. So I will get that 30,000 sample points. So if you are done earlier unticking this one, you will get only this many points. 5,000 last 5,000 points only you will get. This is how you have to enter this one, and simulation you have to do with the fixed step, not this variable step. You have to use fixed step, and fixed step you are getting from pressing Control E, or in modeling model settings, and here you will get fixed step and ODE4 you have to use for all the experiments doing in control system. Otherwise, people to people, some changes might be there. So if you are having doubt, you can share your graph. You can share your screens.
Sir, my window of workspace is missing. Like it's not showing there.
Yeah, workspace is missing, then no problem. It is having a workspace. You can go to this window. Window will be there.
Layout near to Simulink layout.
Now here, this MATLAB, that window you have to select. Uttam, what is your issue? You can share your screen also. You can share your screen if you are having any doubt. All of you completed up to this.
So when I try plotting in command window, like I type plot out dot x out dot t out dot y, but I'm getting some error. I don't know.
What are the showing?
It's showing
Can share your screen.
data must be okay. Yes, sir.
Yeah, you have to plot t comma y. Out is there. Yeah, plot out dot numerical determinant. Yeah, you have to go to that Simulink. Go to Simulink.
Simulink, I think I closed it.
Go to Simulink.
I think I closed it.
And close that one. You have saved those files.
Like I. Mhm. I can. Sir, can I seeing the screen?
Yeah, I am. That Simulink is not at all open now.
Oh, okay.
Yeah, you click on that out.y, double click on that out.y. Yeah, this save format you change the time series to array. Okay. And that is 3D. Okay. This here also. Time series to array. Then run it. Now up arrow. Yeah. Enter it, you will get it.
Okay.
Now your simulation time is 0 to 10 only.
Okay, 10.
Yeah, you are using the step from 1. Step time is 1. So you have to make it 0 and the simulation time to some 30 seconds.
Okay. Thank you, sir. I'm stop sharing this.
So if you want to see something like this current working folder, something like that, you can click here this layout and this here you can click these things. You can either click this default, it will be setting this 4 tabs. Yeah, you can enter the script file here and you save it and run it. So it will show here in the workspace. Now you have to double click on this transfer function. And this numerator coefficient is 1. If you are having any other new coefficient, you can directly enter here. And this m, b and k, m space, b space, k, that will be ms square plus bs plus k. So you can directly enter m, b and k. These are the small letters, so here also you have to put the same. Clear now? Okay.
So when I'm trying to plot the graph through plot bracket out dot t comma out dot y command, it's showing some error.
What are it is showing time series something written over there?
Yes, sir. Time series slash plot.
Yeah, that is why I told you earlier. You double click here and make it array. Save format here array. And again you run it. After run it, you can just go to command window and plot it. You are giving some time series, that is why it is showing like that. If you make it array, it will work. Now you are getting.
Yes, sir. No, it's. So what's the difference in the all the options that we are choosing? Array, time
You will
space.
create array only, structure array, and these things you are studied in C now.
Yes, ma'am. So
The C program, same things only, structure and array. And this time series is, it is creating a series with the time. It having first is some time and then this data points. So time and data point is same, saving the same time. So if you are using a time series, now you are plotting out dot y comma out dot t, that having this time scale the first rows. So you have to select those rows in between. So array means it is creating on array only. That values, whatever it is creating that array. That array name is out dot y. And it is also creating a time vector. This t out also it will create. The t out and this t are same only. This t out and t are same only. The t out is creating this out also. Out is directly creating on time series also. That time is t dot t out. So you can either use t or t out. Y as output and t out and t will be same. Both are time only. But we are giving a clock to monitor the time. In earlier versions of MATLAB, this option was not there. So we have to use this clock. Now they are integrated this clock also to this. So you will get time also from there. So this is how you have to enter a transfer function and plot the response. So what should you do if you want a step plot of this one? So you are getting a plot that is a simple plot. You are right clicking this one, you will not get anything like what you are done earlier. So the step response, step info, like that things you are done for a linear system. Step info will give you rise time, settling time, like that things. So those times, those parameter values you are getting from step info. If you are giving a step input here and your display is there, you will not get the step info. That is rise time, settling time. Those things you will not get from this t dot out, this to workspace option or this scope. So for that purpose, you have to use linearization toolbox. So linearization toolbox you are using, you can right click on this line. Right click on this line, linear analysis point, input perturbation. And this line, output line, linear analysis point, output measurement. So right click on this black line, linear analysis point input perturbation. This output line, input line linear analysis point input perturbation, output line, this line, linear analysis point output measurement you have to click.
Sir, I'm not getting the options.
Yes, sir.
Linearization.
This option is there, linearization.
No, sir. When we right click on the wire, it is not coming. Like,
So you go to this Simulink library browser. This control system toolbox is there.
yes, sir.
Yes, sir.
Model linearizer is not there. This is hidden only, no?
Not available, sir, this option.
This option is not available means some toolbox it is missing.
So
So it's available in 2028.
Yeah, this toolbox something you are not installed, it will miss. This linearization option
I
is there.
think
no, sir,
statistics.
we have only simulation, debug, modeling, format, and app. We don't have linearization.
Linearization is not there now.
Not there, sir.
That might be the problem. If the linearization toolbox is added, then it will come. So somehow you have to add those things. Otherwise, you cannot do this linearization things. So I will explain how it is doing. So right click on this line. Model linear this. Right click on this line linear analysis point. Input perturbation. And here your output line you have to do output measurement. Then go to linearization, model linearizer.
Sir,
But
sir, we have that linearizer option, Simulink control design toolbox, sir.
yeah, then you can use those blocks.
We have to install that toolbox also.
Yeah.
It is showing the model linearizer.
Yeah,
app.
there you can use input perturbation here and output measurement here. And then you will, if you are using linearization, you will get the linear analysis toolbox. This one.
Yes, sir. It is in simulation control design toolbox, sir.
Yeah. So this linear analysis, now you have to click this step. Step means it will give the step response of the system. So you will get step response like this. If you are right clicking this characteristic, peak response, settling time, rise time, all the things what you are done earlier, you will get it. So earlier you are getting only on plot. Here you will get step response. So what do you mean by step response?
Sir,
What do you mean by step response?
sir.
The response of the system when the unit step is given as an input.
So if I am giving this kind of input, what you will expect? Now it is 2. So I am giving a 2 as input. What will happen to step response? You are telling about 1. If you are giving 1, you will get step response. If you are giving 2, what will happen?
So repeatedly
It's scaled by
like
factor of
scaled version of unit step response.
So what are the quantities it will change? These characteristics.
So the peak will change. A peak overshoot will change. The
Peak
settling
will change.
set 2% settling will change. That time, sorry, the magnitude of final settling.
You just we are giving two, these are the characters: peak response, set-in time, rise time, and the steady state value. Only thing changes the steady state value. I think other things will be remain constant.
Sir,
No,
peak
sir, the
response.
overshoot peak should also change, right?
Or
The fluctuation magnitude will
the
change.
percentage of overshoot, the percentage overshoot will change it or not. This peak amplitude will change here.
Yeah, the peak amplitude will change, and
The
steady state
amplitude will change.
also
That
will
percentage
change.
overshoot will change it or not.
It will not change, sir.
Why?
Because we are taking percentage.
What?
So,
Why it is not changing? Percentage overshoot. Rise time will not change. Set-in time will not change. If it is changing, you can tell me. It is not changing. Abhay Dilip,
Yes, sir.
it will change or not?
What did you ask, sir?
Rise time will change it or not? If I am changing the input amplitude 1 to 2.
I don't think time will change.
What? It will change it or not? Rise time.
I don't think so.
Hmm?
It won't change.
Why it is not changing? Neha,
Yes, sir.
Neha,
Yes, sir.
it will change it or not?
Sir, I'm not sure.
Okay. So you are dealing with a linear systems. So linear system property, the characteristics are linear system properties. So if you are giving 1 or 10 or 100 to a linear system, the response will be remains as it is. So this raise time taken from here to here, and this overshoot, this set-in time, those things will not change. That is why it is called a linear system. That is the only purpose you are using unit step response. So if it is changing with the amplitude, what is the use of taking unit step response? There is no use. If you are using a unit step response, there is no use of doing that. Because here this 1 volt is available, we are doing that. Unit step means that input is 1, calculations are easy. So you are doing that purpose only. It will not change with its amplitude for a linear system. It is only valid for linear systems. So non-linear system, you have to do something else. For a linear systems, these parameters will be remains as same. That is the only purpose you are using unit step response and your arguments are, if this is true, it is true for all. This is only the case you are using all the time unit step response or unit ramp response or unit sinusoidal response. So what is the peculiarity of sine wave? Sine wave is giving you a system. What should be the output?
Sir, it depends upon system.
Depends upon system. So if it is a inductor, if you are giving a sine wave, output will be
Cosine wave phase shifted by 90. Sine wave.
yeah. If you are giving a capacitor, then
Again phase shifted by 90. Minus 90.
if you are giving a sine wave, you will get output sine wave only, but there is a phase shift. So sine wave is giving you a linear system, output will be a sine wave. Depending upon that system, this phase angle will change. And this is the only signal that is giving you a linear system. It will retain like that. If you are giving a step signal like this, it will be output will be something like this. It will not follow the step at these points. But sine wave property, it will be a sine wave. Output also be a sine wave, but phase shift is there. So this is called the high frequency or low frequency part here. If you are giving a step input, this is high frequency or low frequency part.
Sir, high frequency part.
That is called a transients. Transient. This is high frequency part. These are all low frequency part. So these things I will ask later. These things I will ask later. Now this is clear now. How to take step response. So step response plot is like this. So this third one is Bode plot. The third one is Bode plot. What do you mean by Bode plots?
Frequency response.
What do you mean by frequency response?
Sir, by the gain or by changing the frequency. The logarithmic scale.
Why you are using logarithmic scale?
Because those many
Because
data points can be it can be shrinked when we use the logarithmic scale instead of, see, for example, 10,000 hertz and 10.
so if we use a linear scale, then we need to draw a very large
Graph.
and y-axis graph. But if you use log scale, it is a we are able to shrink.
Shrinked version.
How to calculate the gain?
Sir, the transfer function of the Yeah, 20 log of the
Why you are
transfer
using
function.
20 log?
Yes, sir.
Why you are using 20 log?
Because we are giving a signal and it's not a power. If it's a power signal, then we would have used 10. Here it's like a normal voltage or current signal. So
Why you are using 20 log? Why you are using log?
Because you're plotting in the log scale.
Log scale is in x-axis only.
for different inputs and different values of outputs, it will be proportional if we plot it in logarithmic scale.
Okay, fine. So for frequency response, what will be the input?
Sinusoidal wave.
Hmm? What will be the input?
So sinusoidal wave.
Yes, sinusoidal wave we are applying, then taking the response, applying a system, taking the response.
Yes, sir.
Yes, sir.
So this is called frequency response. So then you are changing something. I am giving a sine wave like this. I will get one response like this. Then you are changing something.
So frequency.
Now I will change the sine wave frequency. Again I will take the response. This response is varying from 0 to infinity. Input frequency I am changing and I am taking the output and I am plotting this gain A is equal to 20 log. This one. And here it is log omega. So making the scale also logarithmic is actually this is log scale. Making this also logarithmic, I am multiplying by 20 log. I am plotting this one. And again log omega versus phase. I will get another plot. These two plots are called Bode plots. So just clicking here, Bode, I will get that response also. Magnitude versus log omega, frequency versus phase angle versus log omega. This called Bode response. This is
So,
actually sinusoidal response. But
so can you again clarify on the advantage of using the board diagram?
yeah, this same only. What you people are told that is same. I can get to this entire frequency range 0, here it is 1, 10, 100, 1000. This entire range of frequency I will get it in a single graph. Here using other than anything other than logarithmic, I will not plot it in a this much of small graph. So that is advantage logarithmic graph. For making here this y-axis also logarithmic, I am multiplying 20 log. And I am applying a sine wave of low frequency first, then frequency I will change, keep on increasing. This amplitude I am keeping constant. This might be 1. And I am taking the response and plotting this one. This is exactly what you are done in your analog electronics circuits. Same thing is there in control system. That is called the Bode plot. You are plotting this phase also. There is a meaning for phase also. So you will study these things after time response analysis. So now I am getting the response of output. So this is ms square plus bs plus k. So I am having something like this. M f x is there, b and k are there. So I am getting this x of s by f of s. So I will get the output x of s only. That response only I am getting. And I apply input f of s I am applying. I will get the response of x of s. So if we are considering this mass, so if it is moving x, then there will be x dot and x double dot will be there. X only I will get it in the output. What should you do to measure x dot and x double dot? X dot and x double dot, how you should get from the output. So that is why you have to do the differential equation analysis. So this differential equation f is equal to mx double dot plus bx dot plus kx. So if you are having like this, you can convert these things using single integrator, or you can use single integrator, or it is called a state space. So you are studied about state space. You are studied
Sir, in this semester.
Yeah.
So we'll be learning in this semester.
Okay, fine.
We haven't yet.
State space, you are having nth order differential equation. You are converting that into n first order differential equations, and you are solving those things. That is called the state space. So you will get a vector matrix vector form, and this A matrix will be there, and this will be a column vector. This is called A2 vectors. So these things you will study later. There is existency of these solutions. A will be that inverse you have today. Inverse should exist for this system. And you have studied about eigenvalues and other things. You have studied, no?
Yes, sir.
Yeah. From here only eigenvalue concept, all our things are coming. So you will study these things later. So if you are having f is equal to mx double dot plus bx dot plus kx, you can use single integrator and you can do the equation. This equation you can convert it to u by integrating those things. So if you are having x double dot here, you are integrating this one, you will get x dot. Again you are integrating, you will get x. So this equation f by m is equal to x double dot plus b by m x dot plus k by m x. So now I am having x double dot is here, integrating x dot I will get, integrating I will get x. So x is multiplying by k by m, x dot is multiplying by b by m. I am taking the summation. then this part is over. Okay. So f by m minus b by m x dot plus k by m x equal to x double dot. So f is there, I am applying, and it is multiplied by 1 by m, and this summation here plus and minus, I will get x double dot. So you will get here x dot output scope, and here you will get scope. So this is how this differential equation is converting to a block diagram with two integrators. So it is second order system. So you have to use two integrator. Like this you have to use. So now you have to do these things. This simple only. After this you can leave for today. So you copy this one, this figure, and do it in Simulink. And converting this equation into a block diagram using two integrators. So I have to open new model. For node model, I have to click here. It will pop up a new model. And here I am using 1, 2 summer, 2 integrator. And these you can consider as a 2 gain blocks. And this one scope and this one gain block. So 3 gain blocks, 2 integrator and 2 summer. These things. And here we can use step. Here you can use scope. These many things are required. So you can start doing. So go to Simulink library browser, math operation, down, summer will be there. You copy on summer, double click on the summer. Here plus and minus. So one is plus and plus only. Another one is plus and minus. So your left right click and drag it. Plus and minus you make it. Plus plus to plus minus. So double click on this block. Plus plus to plus minus. So it will be plus and minus. And now you have to flip this block. This block is coming this direction. So for flipping this block, you have to either right click here, and here rotate and flip, and you can flip block, or Control I you can press. Control Alt for rotation in clockwise direction. Control Shift R is counterclockwise direction. For flipping the block, Control I. Now I require gain blocks and two integrators. So two integrators is available in continuous blocks. Continuous blocks integrator, drag and drop it here. Again, right click and drag it here. So two integrator is here. Now I want gain blocks that will be there in math toolbox, math operations, gain. This also I have to flip Control I. Control I. Right click and drag it. Again, I will get second one. And one more gain block. Directly I can copy, drag and drop it here. Again, I need sources, step, and from sinks, scope, and to workspace. Workspace I can make it Y1. Now I have to patch up these things like this. From here, you have to drag it and keep it here. So Control R, you press it. Control R. So Control R, you press it. You delete this one and this one connect here and this one connect here. This out, you can connect it to here. Now this is 1 by m. So 1 divided by small m. These two integrators, this one is k by m and that one is v by m. K divided by m. V divided by m. Step 0, final value is 1. Here out dot 1 is time series to array. We connect it here. Simulation. Control E. Model configuration parameter.
Sir,
But
could you please wait for 20 or 30 seconds so that we can
yeah, I
come
will
to you?
explain. You don't worry.
Okay, sir.
So this figure you are take it down. No?
So just a moment.
This figure is this equation only. If you are having any doubt, I will explain. This f is equal to mx double dot plus bx dot plus kx. So now I am converting these things to first order equations, and after that I am integrating. So this x double dot I will keep it there, and I will do the rest. So if you are having available x double dot, we are integrating that one by s. This 1 by s is the integrator. You will get x dot, and again you are integrating, you will get x. This Laplace domain, you can neglect the initial condition. So you divide this by f by m is equal to x double dot plus b by m x dot plus k by m x. So you will get x double dot from f by m minus e by m x dot plus k by m x. X double dot. So I want this one now. So x I am having multiplied that x by b by m. This capital M, B and the small m, it will show error. This is K by M gain block. This is B by M. These two things I am adding. And this output I am taking. That I have to subtract from F minus A. F is the step input I am giving. F. So F multiplied by 1 by M. This and that I have to subtract. So plus minus here I will get X double dot. This is X output and this will be X dot. Here you will get X double dot. So this is the step input, that is force I am giving as a step input and output I am taking from here. So this is on gain block only. This is on gain block. This also gain block. This is summer. But the summer here plus and here minus. But this summer is plus and plus. This is summer only and this is integrator. This one also integrator. So you take it these things. So I am using this B and small m, K and small m and 1 by m. Those things I am used here. B, K and m. These are the small letters. So here also I am using those small letters. So this one I am mimicking here. So I have to use two integrator. So two integrator is available in continuous block. So in Simulink library browser, you go to this continuous block. This integrator is there. Drag and drop here. And you right click and drag it. You will get second one. So integrator is ready. Integrator is available in continuous block. Drag it. So second one you can go again from here also you can drag it and drop it. So if you are defined those things, that control E you have to press, model configuration parameter, fixed step size is 0.001 and solver type is Rangakutta 4. And you run this one. So integrator is ready. Now I have to go to math toolbox, math operations. And this gain block you can drag and drop. Now I need 3 gain blocks. 2 are flipped this like this. 1 is like this. So I have to collect the 3 gain blocks. Either you right click on gain block and here rotate and flip block. Otherwise you can click this one and control I you can press. So control I for flipping that block. Gain blocks are available in math operations. For 90-degree rotation clockwise, control R. Anti-clockwise, you can use control shift R. What is that arrow shape? This one. This is gain block.
The other arrow shape blocks.
Which one? Here, this one.
Above that.
This.
Yeah, yes.
This is that this gain block only.
Only.
Gain block I clicked control I. So it will flip that block. From here only signal is coming here. So input is here, output is coming here. I flipped this two gain blocks. This is as available in MATLAB Simulink. So these are created. So this scope and sync I just drag and drop it from scope and syncs, and this two workspace option also I drag it from syncs. Now these two summer blocks. Summer block is available in this math operation. Extreme down, sum is there. Drag and drop it here. You can press Ctrl R for rotation, rotating this, and this is plus plus. If you want to make plus minus, double click on that list of signs, make it plus and minus, and you connect all the things. Here you run the Simulink file and script file. If your parameters are available in Workspace, you run this file only. This gain values, this one is 1 by m as like as here now it is 1 by m, b by m, k by m. So here you will get x double dot, here x dot, and here x. So you drag and drop this here, and you can get x dot from here and x double dot from here. You run it, so you will get the exact same thing as you are done earlier in this scope. So simulation time make it 30, run it. So you will get exact copy of that one here also. But extra thing you are getting is you will get the x is the position, x dot is the velocity, you will get it from here, and the acceleration of the system you will get it from here. So if you are converting this into like this model, differential equation to Simulink model, you will get x dot, x double dot, and x. We are converting entire thing you are doing in Laplace domain and you are converting, you will get that x of s to f of s only. The parameter x dot, that is velocity and acceleration parameter, you will not extract from there. Otherwise, you have to use special senses for that purpose. So for simulation, if you are doing like this, you will get those parameter also. So all of you are completed.
Yes, sir.
Yes, sir.
So those who are complete, they can leave. Others can wait.
Sir, we are bringing that out.y1 in form of an array in Workspace, right?
Yeah,
Okay.
Everything is in array only. Don't use a time series. No, you don't have to submit report for this lab also.
Sir, can you again show how to use that linearization thing?
Yeah. Here, right click, linear analysis point, input perturbation, and here you can click it, output linear analysis point, output measurement. And then go to this linearization, input perturbation and output measurement. Then model linearizer, then step.
Okay, sir.
So what are these the features of this linearizer?
Model linearizer.
Yeah.
Yeah, model linearizer is using for some other purpose only. It is actually linearizing your model only. If you are having some non-linear functions or non-linear elements in your system, suppose you are having some non-linearities in your system, you are having with some system, so it will linearize this point to this point. So it will linearize using that input output linearization technique is there. So a small perturbation it will give, and output it will measure, and it will linearize. This is you are done in your that amplifier circuits. You are done your amplifier circuits. Yeah?
Yes, small signal model.
A small signal model. That one only. It is actually input it will small perturbation, output it will measure, and it will make the system linear in this range. So that thing only you are using there. But it is a linear system, so it is linearizing means it will linearize for the complete system. For a non-linear system, linearization, so many methods are there. One of the method is input perturbation and linearization. And feedback linearization is there. So many things are there. So those things you will study if you are taking control system, electives, the third one. Second one is this is control system, and advanced control system is there. And after that you will study this kind of things. Advanced control system is dealing with the most of the parts, state space analysis, controllability, observability, like that things. After that you will study nonlinear system, then nonlinear dynamical system or some courses. You will study how to linearize, how to do a nonlinear controller. So many things you will study that time.